Okay, so right now I am going to do number 29 in your review packet. We're going to solve the equation. So what I notice here is that I have this expression here, and it's being raised to 3/2 power. My goal is to isolate my x, which is my variable. But x is kind of attached to this -5 here because all of it is being raised to the 3/2 power. So I want to be able to free it from this kind of cage that this 3/2 power is putting around this, this expression. So in order to do that, we have to make sure that we are raising x minus 5 to the first power to get rid of this, this exponent up here. Because anything raised to the first power is itself. So that'll help us isolate x because we will no longer have this exponent which is trapping it. So let's go ahead and do that. We're going to try to make it raised to the first power. So the first thing I'm going to do is I'm going to say, okay, x minus 5 is being raised to the 3/2 power, but I'm going to go ahead and raise that to the 2/3 power. I'm going to raise it to its reciprocal because I know that by rules of exponents, when I have something raised to a power and then raised to another power, I go ahead and I multiply those exponents. And so I can see here that 3 times 2 is 6 and 2 times 3 is 6, which would leave me with 6/6, which is 1. And so x minus 5 to the first power would just be x minus 5. So I know that whatever I do to one side, I have to do to the other. So I've raised this side to the 2/3 power. I'm going to go ahead and do that to this side. 27 to the 2/3 power. All right. So now, since these exponents kind of cancel out, let's just look at that here. We have x minus 5 to the 3 times 2 times over 2 times 3, which is 6/6, equals 27 to the 2/3. And I know that 6/6 is the same thing as 1, so I can go ahead and just drop that. So I'm left with x minus 5 equals 27 to the 2/3. The next thing I want to do is try to figure out what this actually is here. What is that number? It's a number, I just don't know what it is yet because it's in this strange form. So what I'm going to go ahead and do is rewrite this number in its radical form. I'm not changing anything about the number, I'm just expressing it in a different way so that I can see more clearly what that number actually evaluates to. So I'm going to go ahead and do that to that side. The reason why I don't have to do it to the left side is because, like I said, I'm not actually making a step towards solving it. I'm just trying to view it in a different light. So I'm going to write it in its radical format, and I know that the guy in the ditch goes in the denominator, so the guy in the denominator will then go in the ditch. Let's go ahead and put our 3 in our ditch. 27 under the radical, and we're going to raise it all to the second power. So we got x minus 5 equals, the cubed root of 27 is 3, and we're raising that to the second power still. We know that this right here is 9, so I'm just going to draw a little arrow here to continue my work. I've got x minus 5 equals 9. And then if I go ahead and I add 5 to both sides, I'm left with x equals 14. And as an exercise, or to make sure that you've actually got the right value, the nice thing about these problems is you can actually check to see if you're right. So you can go ahead and plug x back into your equation and see if you get the right answer, and see if the equation is satisfied with x being 14. And I'll tell you right now, yes, this is the answer, but on your exam you can make sure that you do that so that you know that you're getting the right answers for these problems.